got another word problem for you involving a quadratic function. So this time you have 200 feet of fencing to use to enclose a rectangular plot of land that borders a river. If you do not place fencing along the river, find the length and width of the plot that will maximize the enclosed area, and what is that maximum area. So it would help in this case to start with a picture, I believe. So let's say here's the river, and you're going to build fencing along that river in a rectangular area. Or let's say I call this the width, I'll call this the length, L. So this would also, if this is a rectangle, which I haven't really done a good job drawing this straight across, then this would also be W on this side, however many feet that is. All right, so let's think about this. You have 200 feet of fencing. That means, and if we want to have maximum area, we want to use up all of that fencing. So when we add up the length of fence along here, plus the length of fence along here, and then plus this length of fence, that the sum should be 200 if we use up all of that fencing. So if we take W plus L plus W, the total should be 200. Well, it makes sense to combine the two W's there, so 2W, W plus W is 2W, plus L equals 200. Okay, so we get that from just the first sentence. We want to use up that 200 feet of fencing. We're trying to maximize the enclosed area. Well, so the area enclosed here would be the area of this rectangle, length times width, for area of a rectangle. And we want the maximum area here. Okay. Well, we want to write this in terms of a single variable. So right now we have the area expressed in terms of two variables, L and W. And so we can't really think about the graph when there are two variables involved. What we can do, though, is take this equation, suppose we solve it for L. And for the record, it would be okay to solve for either variable. L just happens to be slightly easier to solve for, because we can just subtract 2W from both sides. So L equals 200 minus 2W. Well, then the area, I'll just write A for area, is equal to, well, originally I said length times width, but if the length, let me use some other color here, if the length is 200 minus 2W, then this becomes 200 minus 2W times W. Okay, well, so another way to write that, if you distribute the W, would be 200W minus 2W times W, so that'll be 2W squared. I'm going to move over here. So area equals, if I just rearrange that, because we prefer to have it with the squared term in front, so this is negative 2W squared, positive 200. Oh, positive 200W, I should say. Move my L up here a little bit. Okay, right, this is the same, this is equivalent to this equation. Okay, so here's our quadratic function that gives the area of this enclosed plot of land. Right, I need this space here. But let me make a note that L is equal to 200 minus 2W. Okay. So this is a quadratic function. It has a negative leading coefficient. It has a negative in front of the W squared, which means the graph is a parabola that opens downward. So parabola that opens downward has a maximum value at the vertex. So if we want the maximum area, we need to find the values associated with the vertex. So the input variable, in this case W, at the vertex is given by the formula negative b over 2a. So in this case, b is the coefficient of w, that's 200, over 2 times a, that's the coefficient of the squared term, that's negative 2 in this case. So this is negative 200 divided by 2 times negative 2, negative 4, and so that'll be 50 feet for the width. If we want the length, well, so with the maximum area, the width we just figured out is 50. In order to find the length, we can apply this formula, 200 minus 2w. So the length will be 200 minus 2 times 50. I'll get rid of this. This parabola's in our way now. 200 minus 2 times 50, so that would be 200 minus 100. The length will be 100 feet. So find the length and width of the plot that will maximize the enclosed area. That's going to be 50 feet. I'll just switch markers. 50 feet by 100 feet. And so the maximum area, if you do length times width, 50 times 100, that'll be 5 with 3 zeros, 5,000 square feet. And so these are your answers to the first and second questions in this problem.